In this video, I will continue to explain the connection between IoT ESP32 MPU6056 and the single point EF. This video is divided into 5 parts, namely main connector, materials list, code analysis, single point EF connection, and final effect demonstration. Okay, this is part 1, main connect. In this part, I learned how to convert time domain accelerometer data into the frequency domain use the Fourier transform FFT. I use an ESP32 microcontroller interface in an MPU6050 sensor to actual acceleration data. The FFT then reveals the domain frequencies and corresponding amplitudes in the signal, which can be visualized or sent to an IoT platform. This is the single point EF for remote monitoring. This is the next is the second part, the materials used. The materials used are for one ESP32 2-point line for 4.2-point line and one breadboard, one MPU6050 sensor, and Arduino IDE and a single point EF. This is the second part, exercise code analysis. This is an Internet of Things IoT project code based on the ESP32 and the MPU6050 accelerator. Its main function is to connect the acceleration data, perform FFT analysis, and then upload the results to the single point EF code platform. I will explain each section below. Each section. This is the first header field introduction. The single ESP32 connects to the single point EF code platform, and via term 3C. Communication used to connect to the MPU6050. A different MPU6050 and a different sensor read accelerometer data. Arduino FFT platforms FFT section term analysis. This is part second. Configuration parameters. Define single point EF connect information. Include username, device ID, and key. Send the Wi-Fi SSID and password for connecting the ESP32 to Internet. This is the initialization object. An instance of single point EF used for uploading data, and the MPU is an MPU6050 sensor object used for reading acceleration data. The FFT and then is FFT configuration. The FFT define FFT parameters. The SMAPLES, SAMPLES SMAPLES is 265 56 256 256. Each FFT calculation uses 256 data points, and SMAPLE frequency is 2000. The sampling rate is 2000 Hz, and 2000 samples per second, and all locate the railways and objects required for FFT calculations for the X, Y, and Z. This is by variable definition. The series sensor data is ACC-X, ACC-Y, and ACC-Z stores FFT analysis with the dominant frequency magnitude amplitude. This is the data upload initialization. The initialize the several ports, several points begin connected to Wi-Fi, SIM and Wi-Fi. Initialize the MPU6050 and set the rate and flatter. Define the single point AO data upload format JSON sector. And this is 7 main loop. The SIM handle maintains the single point AO connection, collect data and perform FFT. Collects data and calculates the FFT with the current acceleration available and uploads it once per second. Its data execution and FFT conclusion. Okay, looking the simplest data points and center them in individual X, Y, Z, co-perform FFT amplitude to calculate the FFT result. And this is 9 FFT calculation and amplitude analysis. Remove DC office term. Calculate the mean and subtract calculation the peak-to-peak amplitude and perform an FFT. Apply a high window and then calculate a sector, and then find the dominant frequency and maximum amplitude. This is the first part, single point AO connect. This is the interface of single point AO after the exercise is completed. The acceleration FFT model will appear opening the model. We will display the acceleration data of the three axes. This is the part 5, final effect demonstration. This video shows the final results. First, this is the code for the exercise. Okay, and then this is the single point AO link for the exercise. Okay, and then I will move the MPU 6050. When I move the MPU 6050, it connects the acceleration data for X, Y, and Z. Allows an FFT transform is then performed on the data for each axis to calculate domain frequency, the predominant frequency of the vibration, magnitude, and the peak-to-peak amplification. And the next is the data will undergo various changes. And the video is in a validation peak. Okay, so my explanation is over. Thank you for everyone.